Okay, welcome back, third years. We're going to go through the solutions to the probability questions from the exam papers that I asked you to work on yesterday. So I'm going to go through all the solutions to these, and you'll notice in Google Classroom as well, there's going to be another set of probability questions for you to work on. And as I mentioned, we're going to have a test next Monday in this. So you can upload your work on these questions if you want to, but you don't have to. You can just correct it yourself based on the solutions that I'm going through here. Okay, first question. Hagar takes part in a chess competition. In each game, she can win, draw, or lose. So there's 3 possible outcomes. And each of these 3 outcomes is equally likely. What's the probability that she wins her first game? So the probability that she wins is one of the outcomes out of the 3 total outcomes. If she plays 2 games, we want to fill out the 9 possible outcomes for her first 2 games. So this is a 2-way table with the outcomes for the first game, win, lose and draw, going down the side. Outcomes for the second game, win, lose and draw, going across. And you can see this outcome is filled in. She loses the first, she wins the second. So filling in the rest of this 2-way table, we get her winning both, winning then drawing, winning then losing, drawing then winning, drawing both, drawing and then losing, losing then winning, losing then drawing, and losing both. They ask us to find the probability that Hagar wins the first game and loses the second game. So there's only one outcome that matches that out of the 9, so that is 1 in 9. Now, the second question here is, what's the probability that she wins at least one of her first 2 games? So we're looking for any of the outcomes that have a win in it at all. This one, this one, this one, this one. She doesn't win either of those. She doesn't win either of those. It's a draw and a draw and a draw and a loss. And this one. And she doesn't win in any of the 4 outcomes there. So the probability that she wins at least one is the number of outcomes that match that description divided by the total number of outcomes, because that's how we calculate probabilities. And that 1, 2, 3, 4, 5 gives us 5 out of 9. And that's how we answer that. Now, I'm going to just keep moving on. If it's going a bit fast for you, you can just pause the video or rewind and go over. And of course, you can ask me questions if you get stuck on anything when you're doing these corrections. So, Hagar plays 3 games in the competition. Work out the total number of different possible outcomes for her 3 games. So, there are 3 outcomes for each game. And by the fundamental principle of counting, we know that we need to multiply the total number of outcomes for each event. So this was the first game, the second game, and the third game. And we multiply the 3 of those together to get 27 possible outcomes. We're then asked to work out the probability that she doesn't win any of her games. Okay, so if she doesn't win any of them, that means she loses all 3. She loses the first one, she loses the second one, and she loses the third one. So that's the probability that she loses the first, and she loses the second, and she loses the third one. It's my first, second, and third. Now, if you're looking at your probability notes, you'll see this, and in probability means multiply. I apologise, I forgot about the possibility of her drawing them. So that's one way that she could not win any of the 3 games. But of course, we could also have her drawing all 3 games. That would also mean that she didn't win any of them. So she could lose all 3, she could draw all 3. Or what else? There's other combinations as well. She could draw and lose. She could do combinations of drawing and losing like this. We've got to work all of them out like this. Or she could lose 2 and draw 1. In different combinations like this. And that's it. So she either loses all 3, draws all 3, loses 1 and draws 3, or loses 2 and draws 1. This is quite complicated. I'll upload the marking scheme and you guys can take a look and see that even if you got this far, you'd be getting low partial credit for this question, and it's probably only worth about 5 marks. I need to double check the marking scheme. Okay, so I'd said that and means multiply in probability. And again in your notes you should see that or means add. So and means multiply, or means add. What does that mean? That means when I'm doing my calculation here, this is 1/3 by 1/3 by 1/3, which is 1/27. Well, the probabilities for drawing and losing are the same as well. So this is also going to be 1/27. And so is this. And so is this. And so is this. So they're all the same. They all have the same probability, but there are 1, 2, 3, 4, 5, 6, 7 of them that need to be added together. So the total probability that she doesn't win any is going to be 1/27 added together 7 times. So that's 5, 6, 7. It's a little bit squished there. So 7/27 is the answer. Now we can't simplify that any further. You can check in the calculator if you want to be sure. Okay, that last question was quite complicated. You have to first of all look at the different ways that she doesn't win any of her 3 games. It's not as straightforward as just she loses all 3, because of course she could draw all 3 or have any combination of drawing and losing, so long as she doesn't win any of them. There are other ways to work that out as well. If you did it another way that you understand and you got 7/27 as your answer, then that's perfectly fine as well. But again, if you're finding that a little bit confusing, take your time, work on it, pause the video, go back over the steps, and then if you're still struggling with it, you might send me an email and let me know. Okay, we're going to move on to question 3, or the second question. John is going to a festival for the weekend. Each outfit he will wear consists of a pair of jeans, a jumper, and a pair of shoes, and he has packed 3 pairs of jeans, 4 shirts. Oh yeah, sorry, he has a shirt as well. So a pair of jeans, a shirt, a jumper, and a pair of shoes. No socks, obviously. 3 jeans, 4 shirts, 2 jumpers, 3 pairs of shoes. Write down 2 examples of different outfits that John could select to wear. We'll just pick the first one in each case. He could have his black jeans, white shirt, black jumper, and boots. Second example, I'll write it exactly the same and I'll just change the last one. Black jeans, white shirt, but any combination would be fine. Black jumper, and sandals. Why would you pack sandals and flip-flops? Anyway, how many different possible outfits can he wear over the weekend? So the fundamental principle of counting tells us that we just multiply all these numbers together. The jeans by the shirts, by the jumpers, by the shoes. And that is 12, 24 by 3. We'll just do it in the calculator in one go. 3 by 4 by 2 by 3. And that is 72. Now, some of them are only going to be subtly different, but there are 72 different possible outfits. Okay, a football strip then consists of a shirt, shorts and socks. Aspen United has 2 shirts, blue and green, from which to select. They can also select from 3 different coloured shorts and 5 different coloured socks, including red in each case. I don't know, I'm not quite sure what they're saying there. There's red on all the socks, I don't know. Calculate how many different strips Aspen United can have. So again, this is just the fundamental principle of counting. The number of different shirts, the number of different shorts, and the number of different socks. So they can have 30 different strips. Willow Celtic plays in an all-red strip. When Aspen United plays Willow Celtic, they are not allowed to use their red shorts. I see what they mean. There is red in the shorts and there's red in the socks. They're not allowed to use their red shorts or their red socks. Calculate how many different strips they can have when they play them. Well, all we're going to do is there's only blue and green in the shirts, have 2 possibilities for the shirts, but now we only have 2 possibilities for the shorts, and we're down to 4 possibilities for the socks. So that gives us 16 different strips. Okay, and that's it. Now, hopefully that makes sense to you. I'm going to upload some more probability questions for you to work on, like I said, and I'll do the corrections of those tomorrow, and we'll also start a new topic tomorrow as well, just a small bit of it. Okay, talk to you soon. Bye.